Hey guys, this is just a quick video on B2 optimization. So I'm actually just showing stuff that I did in class today because I am. And what we did in class today was we summarized B2. So our test is on Wednesday. The whole B2 is just about trying to find the optimum values, like the max or min of something, given a fixed amount. So we kind of categorize things into 4 categories: measurement, distance, profit, revenue, and number sense. So we solve each question in a similar way. We create an equation, which is definitely the trickiest part. In terms of one variable, we find the derivative of that equation, set it equal to 0. Since the derivative gives us max and mins, and that's what we're looking for, since it gives us the slope, and when we set the derivative equal to 0, that's what gives us the max and the mins, remember? Because the slope is 0 at a max or a min. And then third step, we just want to make sure we're answering the question that's actually being asked. So these are the ones I gave you guys in class today. So let's just check one of them out. So say we're talking about the pens, the animal enclosures. Okay, so we got 2 pens, one with one common sider being built with 60 meters of fencing. So here's a diagram of the pens. It says that one pen must be a square and the other one's going to be a rectangle. And we want to find the dimensions that will maximize the area. So to do a question like this, since we know this guy has to be a square, we want to make all the sides the same length. So we'll call all the side lengths x. And then as you can see, this side will also be length x. And then these other 2 sides we will call y, because we don't know the length of them. So we don't want to use x. Okay, so we know that. We also have some information with the 60 meters here. And that's telling us the perimeter. So we've got 1, 2, 3, 4, 5 x's, so 5x, plus we've got 2 y's. 2y is equal to 60. So this is an equation about perimeter, but it gives us some information, so that's cool. Okay, so then we're trying to maximize the area. So I'm thinking we need the area formula. So the area of this pen would be length times width, and you can see the length is actually x plus y, and the width is just x. So our area would be x times x plus y. Or another way to write that would be x squared plus xy if we expand the brackets. So that's our area formula. And this is what we want to maximize. But right now we've got x's and y's, and we just want this in terms of one variable, x or y, whatever. So if we could isolate y from this perimeter equation, then we could actually replace this y with something different. So I'm just going to isolate y in this equation. So 2y equals 60 minus 5x, and if I divide everything by 2, I get y equals 30 minus 2.5x. So now I can just substitute this in for y. So I'm just going to do that down here. So area equals x squared plus xy. And we know that y is actually equal to 30 minus 2.5x, I think, or something like that. 30 minus 2.5x. Yeah. Okay, sorry. Right, so we're doing this. Okay, sorry, I gotta distracted. Okay, so I subbed in y, so then I'm just gonna expand my bracket. So I got x squared plus 30x minus 2.5x squared, and if I combine my x squared, then I get negative 1.5x squared plus 30x. So now I've got an expression for area in terms of one variable. Perfect. So now I'm going to find the derivative of that. So I'm going to find the derivative of a. So a prime of x is equal to negative 3x plus 30. And I'm going to set my derivative equal to 0 to find my max. 30, so 3x equals 30, and x equals 10. So I know that y is equal to 30 minus 2.5x. Therefore, y is equal to 5. No, just kidding. I don't know. 30 minus 2.5 times 10. Yeah. Cool, y is 5. Alright, awesome. So that just means that when I do my drawing, I know these are all 10 by 10 by 10, and this is 5. Awesome. Okay, so that's just how you do the measurement question. I'll just show you quickly how to do the rest. So cylindrical can with a volume of 1,000 centimeters cubed. If I had to do that one, I'm trying to minimize the surface area, and I know the volume. Okay, so I'm just gonna do that over here. So I know the volume is 1,000, and I want to minimize the surface area. Okay, so I feel like volume and surface area are going to be the formulas I need. So I know that volume of a cylinder is pi r squared times height. So if I sub in 1,000 for volume, pi r squared times height, there you go, I got one equation. And then if I find an equation for surface area, I got surface area is equal to 2 pi r squared plus 2 pi r h. So my expression has r's and h's in it, which I just want it to have one or the other. So if I isolate this expression for h, just do that over here, h would be equal to 1,000 divided by pi r squared. So now I can sub that in for h. So I got 2 pi r squared plus 2 pi r, and then h is actually 1,000 divided by pi r squared. Cool, so now I have surface area just in terms of r. And I think I'll just cancel out the pi's. I'll cancel out 1r. So my expression can be 2 pi r squared plus 2 times 1,000 is 2,000 over r. And I'll just find the derivative of surface area. I think it might be easier to do 2,000 r to the negative 1. So then when I find the derivative of s, I can just do 4 pi r minus 2,000 r to the negative 2. And then I just set that equal to 0 and solve it. So I can move one of these over, cross multiply, multiply by r squared, whatever you want to do. So solve it for r. And then you'll find the radius. Okay, I'm just moving through these. I'm not fully solving them. Okay, next question is the lifeguard. No, well, I didn't call it that, but this guy right here, Billy, is trying to rescue his girlfriend, Billie Jean, who's stuck on the other side of the river. These ones are kind of weird, but we know the width of the river is 100 and the length is 300. So we want to know the fastest time he can rescue Billie Jean. So I mean, a one route option is Billie Jean, or Billy, whatever his name is, could just actually go straight across the river 100 meters, and he swims at 1 meter per second, so it would take him 100 seconds, and then walk the 300 meters over to her. So there you go. And he walks at 3 meters per second, so if he's doing 300, it would take him also 100 seconds. So we're looking at 200 seconds total travel time. But what if a faster route would be for Billy to, I don't know, like walk down here and then swim diagonally to her? I don't know. Like, there's multiple path options. Or should he start here and swim this way and then go there? Or would that matter? So we need to figure out the best route choice for Billy to get him to his girlfriend the fastest amount of time. So we're going to set up an equation to let him take whatever path he wants. So we're going to assume he enters the water at some point. So let's just say here, but it could be anywhere. And we're going to call this distance x. Just kidding. How do I want to do this? Just rethinking it here. You know what? Let's just... I don't know. I think you'll get the answer either way. I was going to say it would go along here and then jump in. Or he'd like swim and then walk. I don't know what's better. Let's swim first. Okay, so let's say we think Billy's going to go like this, get out at some point, and then run to his girlfriend. Okay, so we can represent this distance by calling it, okay, no, wait. See, I told you it's hard. Okay, here's what I'm going to do. I know the total of this red line and this purple line have to add to 300. So I'm going to call this distance x, and I'm going to call this purple distance 300 minus x. So the total of them will add to 300. I know this distance is 100, this red dashed line. So to get this purple distance here, I kind of have to do Pythagorean Theorem to get this diagonal distance. So this would be x squared plus 100 squared to get the length of the hypotenuse. So now I know the distance that Billy's traveling is this, x squared plus 100 squared square rooted, and then 300 minus x. So that's his root choice-ish. So x could be anything. X could even be 0. Okay, so I'm thinking the equation we want to set up in terms of time. Time is distance divided by speed. So the distance he's traveling at first is in water, which is x squared plus 100 squared. And in the water, he's going at 3 meters per second. Plus, when he's walking at a distance of 300 minus x, and he's going at a speed of, oh, I messed that up. This one's swimming, this one's walking. So there's an expression that I can use, an equation I can use for time. And now I just want to find the derivative of this, and then set that equal to 0 and solve. That's the tricky part of this question. So making the equation, distance divided by speed for time, and then just figuring out the two distances, and then actually getting the derivative of this and solving it is the tricky part. But I'll leave that for you guys. Okay, next question. Outdoor concert. Okay, so here's our classic revenue question. So we're saying we're finding the ticket price that maximizes the revenue. So let's say the revenue that they're going to take in from this concert is $30 per person, and then they're getting 5,000 people to go. So they could potentially earn $150,000 from this concert. But they want to know, should I increase my ticket price by $1? But if I do, I'll get 100 fewer people. So let's add that to our revenue equation. Let's say instead of $30, we're going to add $1. And I'm going to put an x beside that to stand for the number of $1 increases. So if we want two $1 increases, then we're increasing the price by $2. But then that also means that instead of multiplying it by 5,000, we'll have 100 less people going. And I'm putting the x there too, just in case I want to increase it by $4 or $5. Then I have to have the same number of people not go. So there's my expression for revenue. So I think the quickest way to do this question would be to expand the brackets and then get the derivative from there. So if I expand the brackets, I get 150,000 minus 3,000 plus 5,000, so plus 2,000x minus 100x squared. And then if I want to get the derivative of that, derivative of r with respect to x, derivative of 150,000 is nothing. The derivative of 2,000x is 2,000. And the derivative of that would be minus 200x. Then if I set the derivative equals 0, I'm just solving the easy ones. 200x equals 2,000, so x equals 10, which I think that's saying that we want to increase the price by 10 bucks. So that means we want to charge 40 bucks a ticket, and we'll only have 4,000 people go, but that'll be 160,000 in profits. Cool. Last question. The green guy. Find two positive numbers. Oh yeah, I didn't write it down. It's gonna be hard to do that. Anyways, product means they're multiplied, so we know x times y equals 200, such that I feel like it said something like when you add them together, like the sum, one number and then twice the other number or something, you wanted it to be like the smallest number, small number. Does that ring a bell? Maybe. So if this is the equation that we're trying to minimize, we want the x and the y to not be two different variables, so you could isolate one of them here. So for example, if you isolated y, you got 200 over x, you could sub that in for the y over here. So you'd have x plus 2 times 200 over x. And then you simplify that, find the derivative, set it equals 0, solve it. Okay, so that's optimization, and those are kind of like, I don't know, a variety of questions that you could see. So we kind of went over measurement, distance, profit, and the number since one got cut short. Whew, okay, awesome. I hope that helps.